decided to use this displacement formula, displacement is equal to initial velocity times time plus 1/2 acceleration times squared, in order to determine the horizontal displacement. However, we don't know the time. Therefore, we are going to use the vertical component in order to solve this equation, since the time is going to be constant between the horizontal and vertical components. In order to figure out the time, we're going to use that same displacement equation. I'm going to label this equation vertical so that we remember which variables we are using, and so that later, when we start using the horizontal variables, we remember how to keep them distinguished. Now let's write out our equation. We are going to add subscripts for each variable to remember that they are vertical. For example, displacement, since it's not displacement x, we're going to say displacement y is equal to initial velocity vertical, which is the y, times time, which doesn't need a subscript because it's constant, plus 1/2 acceleration, which is also a y, times squared, or time squared. Now we are going to substitute our variables. The vertical displacement is negative 40 meters. The initial velocity is 0 meters per second. That's multiplied by the unknown variable time, plus 1/2 times acceleration, which is negative 9.8 meters per second squared, times time squared, another unknown variable. Now we are going to simplify it. We have negative 40 meters is equal to, since this cancels out, because this is 0, we have nothing there, plus negative 4.9 meters per second squared times time squared. Now we're going to divide this by negative 4.9 meters per second squared. We are going to get 8.16 seconds squared is equal to time squared. Now we just take a square root of each of these, and we get 2.857 seconds is equal to the time. Now we're going to put this back into our variable chart. So the time for both is 2.857 seconds. And now we are going to use this to solve our horizontal component. So I'm going to make another equation labeled horizontal. Make a nice line so I can differentiate. And then since I mentioned earlier, we're going to be using this displacement equation. I'm going to write that out again. Again, I'm going to use subscripts for each of the variables, so I remember that they're horizontal. So Vix times t plus 1/2 ax times t squared. Then we are going to plug in our variables. We have our unknown variable, displacement, is equal to the initial velocity, which is 7.1 meters per second, times the time, which is 2.857 seconds, plus 1/2 times 0 meters per second squared times our time, which is 2.857 seconds. Now we're going to simplify it. Our unknown variable, displacement, is equal to 20.285 meters plus 0, since everything else cancels out due to the 0 meters per second being multiplied. And since that's 0, we get that our displacement is equal to 20.29 meters. Brilliant, Sherlock. But do you know what this means? This means that the perpetrator was 20 meters away from the victim when he or she threw the rock. Yes, but do you know which suspect was 20 meters away? Annie Jones!
What do you want?
Annie Jones, you're under arrest for murder.
No! You're under arrest. Wait, no.
No!
You're under arrest for killing your husband. Anything you say in court can and will be used.
I'm happy he's dead.
Justice.
I'm happy he's dead.